All right, let's go through the solution for test number 3. The first question says, let f be a twice differentiable function. F of 0 is 4. The derivative of f is given by f prime of x equal to sine of the quantity x squared minus 2x plus 1, and we're looking between negative 2 and 2. This is a calculator active question, so and it's crucial for question A, and a lot of you didn't think about it properly and made some errors here. Let's talk about why. It says find all values of x in the interval between negative 2 and 2, at which f has a critical point. Classify each location as a relative min, relative max, or neither. Justify all of your answers. So part of the problem here is a lot of you noticed that you could just take the x squared minus 2x plus 1 and factor it. And you know sine of 0 is 0, so you set x squared minus 2x plus 1 equal to 0. You factor it, and you only got one answer. That's not the only time that makes this equal to 0, because sine is not only 0 at 0. Sine is also 0 at pi, negative pi, 2 pi, negative 2 pi, and so forth. So there's other values that produce this. What you should have done is you should have gone and graphed the function, the derivative here, and see where it crosses the horizontal axis between negative 2 and 2. This is a calculator active question, so you can actually use your calculator to solve for those points. It's just like finding a point of intersection, except you find a 0, and you take all the zeros between negative 2 and 2. By the way, sine is defined everywhere, so there's no places where, there's no critical points from where the derivative is undefined. So if you go take a look at the graph, I'm going to use Desmos, and the graph equals 0 at 1, which a lot of you found, but it also equals 0 at negative 0.772 and negative 1.507. Okay, so those are three values that we should have gotten from this. All right, I should have started writing something down here, but I didn't. All right, so we know f prime of x is this sine of x squared minus 2x plus 1. And so we want to set f prime of x equal to 0. And again, at this point, because it's a calculator active question, you use your calculator. So the solutions that you get are, you get 1, as we saw. We got this negative 507. And x is approximately negative 0.772, perhaps. I'll go look. All right. Now, the second part of the question is, we have to classify each of these as a relative min, relative max, or neither. Now, of course, we have to, as it says, justify our answers. If we don't tell them why we think this, then we're not going to get full credit here. So I'm going to go back and read the phrase. Each is the location. Okay, so let's go here. Let's start with at x equals 1. There is neither a rel max or rel min, because f prime is positive before x equals 1 and f prime is positive after x equals 1, or something like that. Okay. Now let's say at x equals negative 1.507, and I don't remember what's happening with this. We'll go look at the graph. We can see the derivative. Look right here, it's positive before and negative after, so there's a relative maximum there. Is the location of a rel max, because that's a horrible, because f prime changes from positive to negative at x equals negative 1.507. And then at x equals this negative 0.772. I think it's the opposite. It is. Okay, we can see this is the location of a relative min, because f prime changes. You're just going to have to rely a lot this year because you're typing everything in and doing less symbol manipulation. You're going to have to be sharp with your explanations here. So we need something like this. Let's go on to part B. It says use the tangent line of f at 0 to approximate f of 0.25. All right, so the tangent line, okay, of course, the tangent line at 0 is going to be f prime of 0 times x minus 0 plus f of 0. I think they told us f of 0 was 4, if I'm remembering correctly. Yeah, f of 0 is 4. Now f prime of 0 is going to be sine of 1. That's sine of 1 radian, okay? 1 radian is about 57 degrees. That's not something any of us have memorized. Well, I don't have it memorized. Most of us don't have it memorized. So our equation of our tangent line is going to be the sine of 1, whatever number that is, times x plus 4. And so, I'm sorry, I got to go back right now. We're doing f of 0.25. So f of 0.25 is approximately the sine of 1 times 0.25 plus 4, which is about 4.210, I think. I'm going from memory here. But let's go type this in. Sine of 1 times 0.25 plus 4. Yeah. 4.210. Notice that it's 0.3, and we'll round to 0, but we still got to include 0 when we write our answer down. If you use 4.21 without the 0, they're not going to give you full credit for that. So let's not lose a point needlessly by being silly with or careless with those mistakes, making silly mistakes. That's what I meant to say. For letter C, on the interval from 0 to 0.25, f prime is greater than 0 and f double prime is less than 0. Is the approximation found to be an overestimate or an underestimate? Most of us got this one right. Since the second derivative, this is the important one here, second derivative is negative. All right, so we'd say something like since f double prime of 0 is less than 0, the graph of f is concave downward, and the tangent line is above the graph of f. So our approximation, I'm trying to think of words here, our approximation is an overestimate. Lastly, letter D. Letter D is an odd question, but sometimes they ask odd questions, so I wasn't afraid to put it on for you. Using the mean value theorem, explain why the average rate of change of f with intervals from negative 2 to 2 cannot equal 1.25. All right. The use of the mean value theorem here is a little bit odd, but if they say use the mean value theorem, then start off using the mean value theorem. Okay, that means you want to verify the conditions. They told us the function was twice differentiable. Since f is twice differentiable, f prime is differentiable, and therefore continuous. So we have continuity and differentiability on the closed interval negative 2, 2. Okay? So there exists a C on the open interval negative 2, 2, such that f prime of c is equal to, I'm sorry, what was that? What am I trying to find here? I don't need f prime to be continuous. I need f to be continuous. So I'm sorry. I lost my focus here. I'm applying this to f. So it's twice differentiable. F is continuous. I don't think that there. F is continuous on negative 2, 2, 1. So there's just a C and open interval. Okay, all that other stuff, such as f of 2 minus f of negative 2 over 2 minus negative 2. Now, they want you to do all that. And then, however, notice that f prime of x is equal to the sine function, sine of x squared minus 2x plus 1. Okay? And we want to know, can this ever equal 1.25? No, because the sine function has a maximum of 1. However, this can never be, is that bad English? Can never be 1.25, since sine has a max of 1. So I don't know why they wanted you to bring up the mean value theorem here to work this out, but if they say use IVT, use MVT, use this, use that, then by all means verify the conditions, because there's some partial credit there at least. Even if you don't finish the problem, you can earn some partial credit for that sort of thing. Question number 2, this is non-calculator. Let y equals g of x be a particular solution to the differential equation dy of dx is equal to g prime of x, with initial condition g of 3 is 7. Select the value of g prime are given in the table above, and the function g is 3 times differentiable. Write an equation of the tangent line to the graph of g at x equals 3. I think most of us got this one right. Since g prime of 3 is equal to 16, this is just really writing 16 times x minus 3 plus 7. And like I said, most people got it right. It was a 1-point question. It's really straightforward. But they ask those sometimes. Get them right. Let h of x be the function defined by h of x equals negative 5 plus x times g of x. So h of x is equal to negative 5 plus x times g of x. Let me double check that. Then we want to find h prime of 3. Some of you made really silly errors here. Like there were a couple people who did take the derivative of the negative 5. They left it as negative 5. Some people didn't apply the product rule. I mean, like I said, silly errors here. And we shouldn't be making those silly errors for something as easy as this question here. Get every point that you can. There's going to be harder questions that you may miss some points on. Don't miss them here. G of 3 was 7. 3 times 16. You could stop there, but that's 55 if you want to simplify it. Okay, moving on to part C. Use a left Riemann sum with 2 subintervals indicated at the table to approximate the definite integral from 3 to 3.4 of g prime and show the computations. All right, so we're going 3 to 3.4 of g prime. And it's a left Riemann sum. So the first, oops, I got the table up here. All right, so the first interval is from 3 to 3.2, so it's got a width of 0.2. And then we're using left, so it's 16. I got to double check. I got distracted for a brief second there by my dog. Yeah, 16, and then the next one will be 30. And the next interval is still 0.2 wide because it's 3.2 to 3.4. The left is 30. Again, you could stop there, or you could do, this is going to be, what's that, 3.2 plus 6, which is 9.2. If you want to simplify it, but you don't have to. letter D. It is known that G double prime is positive between 3 and 4. Is the approximation for C an overestimate or an underestimate for that integral? Good reason for your answer. A lot of you answered this with poor reasoning or incorrectly because you gotta do this from not from a tangent line perspective, but from a rectangular perspective. We're using left-hand endpoints. Okay, so two things. Since G double prime is greater than 0, G prime is increasing. Okay. Also, actually, let's do it this way. Therefore, the left Riemann sums will be underestimates. Because remember, if the graph is increasing, it doesn't matter if it's concave up or concave down, the left-hand endpoint is going to be the smaller endpoint. So all the rectangles are going to lie below the curve. You don't have to tell me the rectangles lie below the curve. All you got to do is tell me that G prime is increasing, left Riemann sums, underestimates. That's sufficient. Letter E. Use the approximation for that integral from part C to estimate the value of G of 3.4 and show the computations. This is a fundamental theorem question. So the definite integral from 3 to 3.4 of G prime of x dx, if we use the fundamental theorem, will be G of 3.4 minus G of 3. Okay. Our approximation way back up here was 9.2, so that goes in over on this side. G of 3.4 is what we're looking for. They told us G of 3 was 7. I don't remember anymore. Yeah, G of 3 is 7. So then G of 3.4 is going to be 16.2. Just add the 7 to the 9.2. That's going to be our approximation here. And we should use an approximately equal to here, or use the word about or approximately. Moving on to the letter F. Use Euler's method, starting with x equals 3 and two steps of equal sizes, approximate G of 3.4, show the computations. So we know x of 3 gives us y equal to 7, and we're going to use equal step sizes, so 3.2 and 3.4. This is this is x sub 0, y sub 2, y sub 0. So y sub 1 is going to be the previous x value plus h, the step size, which is 0.2 times the derivative at the previous value. So the derivative at 3 is 16 right here. What is this? This is going to be 10.2. Again, if you're unclear what I just did there, because I said that kind of quickly, this is the derivative, dy over dx, evaluated at x equals the previous value 3 over here. I just circled it if you didn't see me circle. Well, the derivative is in the table. That's g prime. And g prime of 3 is given to be 16. Okay, so going back here, the second one's going to be that 10.2. I'm putting it as a subscript. Plus another equal step size. And I forgot the ability to write. Times g of 3.4, which I got to go back up to the table. G prime, excuse me, 3.4, which is 30. No, not 3.4, 3.2. Got to use the previous x value, so 30. I said the right y value, I just said the wrong x value. Oh, what's that? That is also 6, and 10.2 makes 16.2. The exact same value. Coincidence? Yeah, I think so. Actually, that's not generally going to be the same thing. Lastly, letter G. It is known that G double prime of 3 is 60 and G triple prime of 3 is 100. Write a third degree Taylor polynomial for f about x equals 3. A lot of people forgot to shift this over and not center it at 0. A lot of you gave a Maclaurin polynomial. So remember, the Taylor polynomial was going to be f of 3 divided by 0 factorial times nothing because it's the constant, plus f prime of 3 divided by, 1 factorial times x minus 3 to the first power, plus f double prime of 3 divided by 2 factorial times x minus 3 quantity squared. And then lastly, f triple prime of 3 divided by 3 factorial times x minus 3 to the third power. And all these values are given to you. So t of 3 Taylor polynomial, third degree Taylor polynomial. And this is exactly equal to, this is the polynomial, not the entire sum. So all of these should be in terms of g. I apologize for that. I made my mistakes, or one of the mistakes I tell you guys not to do. So it's a good learning opportunity for you guys. Don't be like me, at least in the making mistakes department. G, 0 factorial is 1, g of 3 was 7, g prime of 3 was 16, so it's going to be 16 times x minus 3 because 1 factorial is still 1. G double prime of 3 was, I think, 30 divided by 2 factorial times x minus 3 squared. Is it g triple prime of 3 100? No, wait, I'm sorry. That's not in the table. They just told us that in the problem. Oh, so I got it wrong. This is 60. Sorry. Put the wrong thing in my head here. And then this is 100 over 3 factorial times x minus 3 quantity cubed. All right, so question number 3. Consider the differential equation. dy over x is equal to 10 minus 2y. Y equals f of x, being the particular solution to the differential equation with the initial condition f of 0 is 2. We want to write an equation with a tangent line at 0 and use it to approximate f of 0.5. Tangent line at 0. Now, so x of 0 is 2. So dy over dx, evaluated when x equals 0, is the same thing as evaluating dy over dx at the point 0, 2. And you need the y coordinate, so this is going to be 10 minus 2 times 2, or 6. So y is going to be equal to 6x plus 2, since x minus 0, I don't need to put that down. And so we're approximating f of 0.5. So that's going to be 6 times 0.5 plus 2, which is equal to, that's 5. Half of 6 is 3, plus 2 is 5. All right, that was all part A. For part B, find the second derivative, the value of the second derivative of y with x at 0, 2 is graph of y was fx concave up and concave down at 0, 2. Give reason for your answer. All right, so if the first derivative is 10 minus 2y, then the second derivative of y with respect to x is going to be a negative 2 times dy over dx, or negative 2 times 10 minus 2y. I want to evaluate that at 0, 2. Then I'm going to plug 2 in to get 6, so negative 12. And since this is less than 0, f is concave downward at 0, 2, because the second derivative of y with respect to x is less than 0. Letter C, find the particular solution. Now, not a lot, some of you thought that this was not solvable, not separable. It is, okay? By the way, they're not going to ask you the question in D if part C doesn't have an answer. Okay, so if you get stuck and say, oh, there can't be an answer here, then you go down to D and say, oh, wait, they want me to use that answer? There's got to be an answer. Doesn't mean you're going to be able to solve it suddenly, but some of you couldn't separate the variables for this one. So dy over dx is equal to 10 minus 2y. We did examples like this, so let's go back and look at your notes or watch the video on several differential equations to get this down. Sorry, I have to make sure to start recording. you can't use addition or subtraction. We have to use multiplication and division to move things around. So this is going to be dy over 10 minus 2y is equal to dx. That's how we separate the variables. Or if you want to move the dy off out here, put 1 over 10 minus 2y, you can do that also. So it might look like this. Those are equivalent. Okay. Now over here, of course, we get x plus a constant. Now on this side over here, we do have to be careful because we should do a substitution. We should let u equal 10 minus 2y. In fact, let me write this down just so everyone can see it. Let u equal 10 minus 2y. So that means du is going to be negative 2 dy, and we're going to need a factor of negative 1/2 to balance this out. Okay? So when we balance this out, we're going to end up with a negative 1/2 natural log absolute value of 10 minus 2y equal to x plus c. Okay? Get rid of this part right here. Some of you forgot that negative 1/2 because you didn't do the substitution. Okay, so that definitely causes problems. Our initial condition was, sorry, I gotta go back up. F of 0 is 2. Is that the same one for this part down here? Yeah, f of 0 is 2. All right, so if we know f of 0 equals 2, so I'm going to plug in 2 for y, so this is going to be 6, natural log of 6 here, and then 0 plus c, so c is going to be the negative half natural log of 6. So we get this. Now I would multiply through here by negative 2 first to get rid of the coefficients in front of the natural log. So this is going to be a negative 2x plus natural log of 6. Again, I just multiplied through by a negative 2, so the negatives cancel, and then the 2 and the 1/2 cancel, leave me this. Same thing's going to happen over here, so it becomes positive, natural log of 6. And of course, x times negative 2 becomes negative 2x. Exponentiate, so we get absolute value of 10 minus 2y is equal to e to the negative 2x plus natural log of 6. You can leave it like this, but it might be confusing later on. Remember, we could separate this into this by our exponent properties. Here, the e and the natural log cancel, and I get 6 times e to the negative 2x. And that's a little easier to handle, in my opinion, than leaving it the other way. All right, so from here, 10 minus 2y is going to be either plus or minus 6 e to the negative 2x. And I'll decide which one later. I'm sorry, I'm just pausing to think if I want to bring it this way or that way. Let's do this. And then divide by the negative 2, which is going to be 5, minus or plus. And yes, we do that in mathematics. We switch the order there when that division happens, just to note that the signs flipped. But we still have to choose one. And remember, this has to go through f of 0 is equal to 2. So just, whoops, I forgot the 6 here. Sorry. It should be a 6. And then when I divided that, it should be a 3. Sorry about that. You guys probably noticed yelling at the screen. When I plug in 0, I got to make sure I get 2. So I want the subtraction. So I get, when I plug in 0, the e to the 0 is going to be 1. I want 5 minus 3 to give me 2 instead of 5 plus 3, which will be 8. So the answer I want here is this one right here. Okay. So this is the solution to the differential equation. A question like this is like a 5-pointer. You're going to get one for separating the variables, you're going to get one for the antiderivatives, you're going to get one for the c, get one for solving for c, and one for finding y. So it's a lot of points, and do as much as you can. And those of you who skipped the whole thing because you thought it wasn't separable, it was make something up and put a plus c on there, and then try to use the initial condition. You might get at least a point or two out of it. Not much, but you might get something out of it. And 1 is better than 0, 2 is better than 1, so do as much as you can. That was letter C. Letter D says to take the limit as x goes to infinity. So the limit as x approaches infinity of 5 minus 3 e to the negative 2x. Because the exponent on the e is negative, the graph is decreasing concave up like this, just the exponential part right here, ignoring the negative 3. So this part's going to 0. So it doesn't matter that we're multiplying by negative 3. That whole thing, that whole second term there's going to 0. 5 minus 0, of course, is 5. And so that's that one. Question number 4. I'm going to pause it and set things up. This might get annoying with me flipping back and forth because of the graph, but I apologize, I am going to do that. The graph of the function g on the interval from negative 5 to 8 consists of a quarter circle and 4 line segments as shown in the figure above, with h, the function defined by this integral. They love to do that on the AP exam. Find h prime of 4 or explain why it does not exist. All right, so h prime of x, let's start there, is just g of x by the fundamental theorem. This is why they love to do this definition here. So does g of 4 exist? Let's go take a look. G of 4 is equal to 2. It does. It's just a point on the graph. They try to put this in a location where there's a sharp turn because they're trying to think, oh, sharp turn, it doesn't exist. Well, the derivative of g does not exist at g because at 4, g prime of 4 does not exist, but h prime of 4 does. It's just that point. So don't confuse the levels. B, at what value of x does h attain its max or its minimum value, on the interval from negative 5 to h, negative 5 to 8. Okay, so we're looking for a minimum. So we want to know, when h prime is equal to 0 or undefined. It's never undefined on that interval, so we got to figure out where g is equal to 0. So where does g equal 0? It equals 0 at 0. Okay, so that's a candidate. Now, there's a couple different ways of arguing this. There's only one critical number in this interval, and the graph is decreasing before 0 because h prime is negative, and then the graph of h is increasing after, so it's always increasing before, the graph of h is always decreasing for x less than 0, always increasing for x greater than 0. So you could actually use the first derivative test for absolute extreme to argue that there's an absolute minimum at x equals 0, or you can do what they call candidate testing, where you're testing the endpoints and then testing the critical numbers and see which one's largest and smallest. Most of us did that, and so I want to run through that one really quickly. So h of negative 5 is going to be the integral from negative 2 to negative 5 of g of t dt. Notice that the limits are in their unnatural order, so I'm going to switch them and make it opposite. And so when I do that, I know what's going on. And then we're going to go find the area of a quarter circle, and then there's a rectangle, and then there's a triangle. So quarter circle of radius 3. We got the negative, and that's below the axis here, so that's already negative. So quarter circle, radius 3, 9 pi over 4, and it's negative because it's below. And then on that same interval, there's a rectangle right here that's 3 more units, so minus 3. And then we got a triangle that's got a base of 2 and a height of 4, but it's also negative because it's below, so 1/2, 2 times 4. So if you work all this out, this is going to be a positive number because all of this stuff in here is negative, and then this one here is going to take the opposite of that. So what does this work out to be? This is 4 and 3, which is 7, so negative 7. So it's 9 pi over 4 plus 7, if my arithmetic is correct. All right, now what about h of 0? That's going to be the integral from negative 2 to 0 of g of t. I don't need to reverse anything. They're in their natural order from -2 to 0. And that's just the area of this triangle. Now, this is negative because it's below. So it's going to be -1/2 2 times 4, which is going to be -4. And then h of 8, integral from -2 to 8 of g of t dt, which is going to be -4 because it's got to get to 0 plus everything that comes after that. We have a triangle with a base of 4 and a height of 2, so which just cancels this area, makes that 0, up to that point. Plus, and then I got a triangle with a base of 4 and a height of 6. Not that 6. This is 8 minus the 2, because I'm separating this into a triangle. It's a little shorter than that point. So 6 by 4 divided by 2, plus the rectangle that lies below, which is 4 by 2. Okay, again, this crosses out to be 0. This is positive, so the minimum is going, absolute minimum is going to be -4. I'm trying to run through this, ladies and gentlemen. That was letter B. Letter C, find the x-coordinate of all points of inflection for H. All right, so points of inflection occur with the second derivative, potentially where the second derivative is 0 or does not exist. All right, so G prime, let's go back and look at the graph really quickly. Where does G prime equal 0? So the derivative equals 0? Nowhere. It would be at this point right here, but the sharp turn makes it not exist. If the quarter circle continued, then we have a horizontal tangent there. But all these pieces are non-horizontal lines, so G prime of x does not equal 0 for all x. G prime does not exist at all of those sharp turns, so that's going to be at -2, 0, 4, and 6. -2, 0, 4, and 6. That doesn't mean all of those are points of inflection. We need to see concavity change. So I need to see this graph go from here at -2. The graph is decreasing before and increasing after. So -2 works. Now at 0, it doesn't work. This is going from increasing to increasing more. And same thing at 4. It's increasing and increasing. So G double prime is positive before and positive after. No good. And then same thing around 4. G double prime is positive and positive. I'm sorry, H double prime. H double prime is positive and positive around those. And at 6, there's a point of inflection. So oh no, my computer's starting to get slow because I keep running all day. Points of inflection at x equals -2 and 6. Because you're going to connect this back to the graph of G, because at x equals -2, G is decreasing before and increasing after x equals -2, and at x equals 6, it's the reverse. G is increasing before x equals -2, I'm sorry, before x equals 6, and decreasing after. Let's continue. I think that was letter C. Letter D. Some of you made mistakes in taking the derivative of this cubic because you were sloppy. We're going to clean that up. And what do I mean by sloppy? Some of you already done this convolution correctly, so I'm not sloppy. And I certainly can be equally sloppy. So I'll take this as me looking at money figures. Put your money back in me. Some of you took the derivative like this when you found k prime. It was 3 times g of x times g prime of x. Where's the square? That's important. We need that. Okay, so now we want Q prime, I think, of 7. Yeah, so that means I need 3 times G of 7 squared times G prime of 7. You're going to evaluate some of these things. So I don't know what those are off the top of my head. So I think G of 7 and G prime of 7 is back into the graph. 7 is right here, and so it looks like we got 2, 3, 4. 1, 2, 3, 4. I'm sorry, it's 5 right there. The slope here is 1, 2, 3. It looks like negative 3. 2, 3, 1. So let's try that this way. 5 and negative 3. Which works out to be that's 25 times 9. So it's negative. It's 9 quarters, which is 225, and it's negative. Letter E, take the limit as x approaches negative 2 of h of x divided by 3x plus 6. Now, on these, on the AP exam, show them separately. Don't melt for stuff like this. We know this is going to equal 0 because the upper and lower limits are going to be the same. I'm not sure you may want to show this. They absolutely love seeing this stuff off to the side. They know you're taking great care to explain to them. This year, of course, it's a little bit different because you're going to be doing less algebra. So just explain to them the words. The numerator is approaching 0 and the denominator is also approaching 0. So we're going to apply L'Hopital's rule. H prime of negative 2, which is going to be G of negative 2. G of negative 2 is. G of negative 2 is negative 4. So this is going to be negative 4 fourths. F, find the value of H of 6. That's integral from negative 2 to 6, G of T dt. Redundant perhaps, but let's I wrote this question. So we did most of this already. We saw that we had negative 4 from negative 2 to 0, positive 4 from 0 to 4. And then from 4 to 6, we have rectangle. I'm sorry, yeah, we have rectangle that's 2 by 2. So plus 4, and then the triangle that's above it, it's got a height of 1, 2, 3, 4, 5, 6, a height of 6 and a base of 2, so half of it. 6, those 4's cancel, those 2's cancel, get you 10. What's down here? G, what value of R? What have you avoided this question? Maybe you ran out of time. Does the series 30R plus 30R squared plus 30R to the n equal the value of H6 found in part F? Show computations. You got to recognize this as geometric. Okay, so 30R plus 30R squared plus 30R cubed plus left plus 30R to the n is geometric. The sum is going to be the first term, 30R minus the common ratio. We want that to equal 10. And so we got 30R equal to 10 minus 10R. When I multiply both sides, so 40R is equal to 10, so R is equal to 1/4. H. Does the mean value theorem guarantee a value C such that H double prime is equal to the average rate of change of H prime over this? No, it does not, because no, H prime is not differentiable. So MDT does not apply. That's the two dies. Let me did again, probably ran out of time. Probably not true. I think it's 1 plus G. You should recognize that as arc length, okay? And in fact, mentioning that, oh, this is the arc length, got you a point, okay? This is the arc length of the graph of G from -5 to -2. And the arc length from -5 to -2 of G is just the uh, arc of the quarter circle from of radius 3. So just, how do you find circumference? Radius 3 is going to be 2 times pi times the radius, but I only want a quarter of it. So it's going to be 3 pi over 2 when you do a little bit of reducing. And that's it. Go study.